Okay, welcome everyone to TAM Lab number 61. Today we're super excited to have Dean Lewis, Amanda Blevins, and Sean Massey joining us. They're going to be talking about the VMware Fling that was recently published, which is all around the folding at home effort, right? So this is a force for good, and how VMware is helping our customers deploy this little appliance and actually help with protein folding and things of that nature. It all started with coronavirus, right? So that's where it started. But of course, there's other projects in there as well. So, all right, I'll stop talking. I'm going to hand it over to, I think, Amanda first, and I'll let you take it away.
All right. Hey, everyone. Thanks for having me. No video because it says the host doesn't let me do that, but that's totally cool. Fine with not being on video. So hopefully you can see my screen. You'll see that I just have 3 slides. And then we'll move into, I guess, a demo or hands-on stuff. So Folding at Home is a project that's been around for about 20 years. And it is focused on understanding how proteins fold. And with that information, scientists can identify what receptors are available and therefore what treatments can happen for diseases, right? So here I took a screenshot from one of the studies that was posted in their Twitter feed and gives you an example of what they're looking for. So like I mentioned, it's been around for a long time. But with the coronavirus and everybody being at home, it became a lot more popular because one, folks were looking for something to do with their time, but they wanted something to do with their time that was a positive effect in the world. So there's a bunch of gamers that found this, and folding can use either CPUs or GPUs. So gamers have a bunch of good GPUs, so do miners, and all of a sudden the world started folding. And they went from 30,000 users to millions of devices in less than a month. And so this project just took off, and it's really nice to be part of a team. And that's really how the work inside VMware started, because just a couple folks said, hey, let's do this together. And all of a sudden we have a Slack channel with over 300 users. William Lamb has put out appliances to make it easier to run on your virtual infrastructure and much more. So what do the stats look like? We really like stats at VMware because it really has a tangible, concrete feeling to the good that we're doing. So these screenshots are from today, if I did this properly. But you'll notice that the Folding at Home network is faster than the world's top 100 supercomputers combined. So if you think, oh, my server's too old, or my computer's too slow, or I don't have a GPU, please don't use that as a reason not to donate your resources, because every work unit is a part of a project that is being studied to be able to cure a serious disease like coronavirus, like cancer, like Alzheimer's, Huntington's, Parkinson's. So you can see for the active CPUs and GPUs by operating system, this screenshot over here, it's just extremely impressive to see the amount of resources that are donated across the globe. And you'll see that our team, Team VMware, is now in 33rd place, and we started over 3,000 place at the end of March. And so the appliance was a big part of getting this going, but also just everybody coming together and having something positive to focus on, I think is what really made it a big deal. And one of the coolest things that I think about this is not just VMware folks are on Team VMware. We have our competitors like Nutanix reporting against Team VMware. We have our partners with Dell and SunGard AS, and our customers really cranking out working units as part of Team VMware. So you can see that we complete over 5,000 points per second, and we complete over a quarter of a working unit per second. And so that's moved us into 1.2 million working units completed and over almost 17 billion points. We'll probably hit that today or tomorrow. So when I spoke with the Folding at Home folks, they said on average, one project has about 100,000 working units. So you can see that Team VMware has single-handedly done the compute and the analysis for 12 projects, about roughly. And I think that's very, very cool. Just one more slide before we get into turning it over for folks for the demo and how it works. What's next for us? So at VMware, we have a very strong partnership with the Folding at Home folks, and we are bringing a work server collection server online in a production data center. So it's treated with the same requirements, resilience, security, processes of any server that we run for production for our business. We will be able to serve up working units and collect them from that server. We'll also have an official giving campaign for folks inside VMware. There's a way to access what we call the global giving portal, and that's where folks can donate money to the charity of their choice, and then VMware matches that. And so we'll have a specific campaign for Folding at Home, so it's easy to find. The folks that maybe don't have the resources to fold or don't have the time to be able to donate their time for the Good Geeks project, there's still an avenue for them to be able to contribute to this force for good. And of course, we always want more team members because that means that scientists will get their results faster. When I was talking with Dr. Greg Bauman, I was asking about, how are the results, now that you have so many folders, and he was very excited, of course, and he's like, I have enough information to write a paper a week. And, for a scientist to write a paper a week, usually it takes a very long time to write a paper, certainly not a week. So you can just think of the amount of information they're gaining to battle diseases, including coronavirus. So with that, I'm going to stop the share and turn it over to, I believe, Dean, and he's going to jump into something of a demo, right?
I am indeed. Thank you very much, Amanda. Okay, so today we're going to look at the VMware appliance that was put together by William Lamb, and we've used and tested quite thoroughly internally, so that you can spin this up either as a virtual appliance on your local machine, maybe in VMware Player, VMware Fusion or Workstation, or in your home lab as well. At the same time, though, everything we've talked about today, you can actually run this software locally on your machines as well, on your desktops and laptops. You don't have to run this as a virtual machine. We've just packaged it to make it easy. So you'll be able to find it on our flings.vmware.com website. And quite nice and easy. We have a handful of documentation for everything that we're going to talk about on this call as well today. So you can download the OVA itself, have deployment steps in PDF, an FAQ, and also instructions for when Sean goes on about using a GPU with the appliance as well. So we'll start off with looking at deploying this in a VMware environment. So I've already loaded the latest FAH appliance into the content library of AV Center that actually is VMware Cloud on AWS. And to deploy that, it's quite simple. We all understand how to deploy a virtual machine, hopefully. And as we go through this, there's just a handful of parameters that really you need to know to get up and running. But we've also made it really simple that you don't have to provide all of the networking config. We can use DHCP, for example. We can use DHCP as long as we've got DNS and access to the outside world. That's all we need for the appliance to run. And we've also made it so that it gets to work straight away. The first configuration item that you need to think about is the size of the appliance. So we've given 3 easy sizes based on the testing that we've performed in-house. You can deploy it and start off small with 2 CPUs and 1 gig. We have the ability to go to medium, which is 8 CPUs and 1 gig of memory. And then large, where we change 16 CPUs and 4 gig of memory. You can dynamically change this CPUs and memory once you've deployed the virtual machine. And when you power on your virtual machine after these changes, the Folding at Home client will pick up the changes that have been made and will be able to continue working as well without any change or detriment. In terms of memory, one of the questions that we get asked a lot is how much memory should we give the machines? And we found that until you start to go to 16 CPUs or higher, you don't need any more than 1 gig on the machine. 16 CPUs or more, even up to 80 or 100 cores, we only need to use 4 gig of memory as well. We've typically seen the appliance max out at around 3.5 gigabytes of memory. Choose our storage, select our networks, and then we provide the parameters. Again, as I mentioned before, we don't need to go in depth in all of these. We can leave a lot of them as they are if you want to. So we can leave blank for DHCP. We can leave our DNS alone as well. That be picked up on DHCP. We don't have to give it a host name if we don't want to, but we're going to fill some of these out for this demo. The only parameters that you do need to input during this build process is the root password. If you don't input a root password during this build, the automated bring up service when the appliance boots for the first time will fail. And you'll see that when you open the console of your appliance, you'll actually see it says vghetto-login rather than the login name of your machine itself. And that just tells you that the first boot process has not worked. We have the ability to enable SSH on the virtual machine, and then we can have the settings for the folding at home software itself. So set a username. We automatically populate as a team ID to join VMware, but by all means, you are more than welcome to join a different team or even start your own team. We do recommend using a passkey. A passkey is essentially an additional authentication for you as a user. It's unique to yourself. And if you are competitive, like myself and Amanda are, then it actually gives you a points boost as well for using that key because you're a validated user every time you upload a completed work package. You can set the mode of the client in terms of how many cores in your appliance it will use. And no matter what you set this to, now during the deployment, you are able to change that after the fact as well. Sean will talk in a little bit more detail about enabling the GPU service. And again, I'm going to show you some of the ways that you interact with the appliance once it's built. By default, we allow access to all IP address ranges, but you can lock this down if you want, and you can use CIDR notation or just a single IP address. We, by default, put a password on for the management aspect of the folding at home client software. That password, VMware1 exclamation mark, but you can also change that to whatever works for yourself. And we have the ability to show the stats in the VM console itself using top, which we'll go through. And we also have some advanced parameters, which I'll show you in a couple of moments when we look at managing the appliance. Okay. So we'll have a look at an appliance that I deployed earlier. We can see the appliance for this one is working on DHCP, but this is the one we're going to be working with today. And if I look at the web console of this appliance, we can see that it's loaded up a customized top so that we can see the resource usage of the virtual machine. We can see that this virtual machine's only been online for 18 minutes so far. And we can see at the bottom that we're actually running a tail of the client logs as well, so you can understand what's going on. So if you wanted no further management ability of your virtual machines, you could simply see it all working from the VM console itself. One of the questions that we hear a lot is that when looking at the logs, you see that you fail to connect to certain IP addresses or you get network unreachable. This is common. The client is trying to contact the work servers to pull down an available work unit so that it can use your CPUs to work through that protein folding as Amanda talked about at the start of the call. Unfortunately, there is not always work units available. However, as I always say, that's a good thing. The goal of the whole project is to ensure that there is no available work units at any moment in time, which means as soon as they're uploaded onto the work servers by researchers, there are machines around the world taking those work units and processing them straight away. And as we can see right now, this virtual machine has not picked up any work units in the last 19 minutes since it was deployed. And therefore, that tells me that at the moment, there is no available work units from the work server. And I would recommend at this point in time that you leave the virtual machine running in the background. It will keep polling those work servers, and it can pull down a work unit when available. So I'm now going to move into my lab. So if you've just deployed the virtual machine for the very first time, you can log into the client interface, very similar to if you actually installed the software locally on your own laptop. And you can see a handful of details. You can again change your identity and the team that you're connected to. You can change the power settings that we talked about in the OVF parameter. We can also set when for it to for the phone at home client to run. So for example, if you run this on your local laptop, you would probably set it so that it only runs when your laptop is idle. But if you're running an appliance, typically on your home lab or maybe on some test clusters of vSphere, then you're probably going to leave these settings by default and leave them at full. You would also see on the interface here a running project as well that you can access, and it will actually give you the project ID. Sometimes the project ID field is not always uploaded as part of the research work unit, but typically they are, and you can track those project IDs and to what research they're currently conducting towards, whether it be COVID, Huntington's, Parkinson's, or a form of cancer. But if you're deploying a number of appliances, then you'll want to use the folding at home control. Folding at home control comes as default installation on the Mac OS X install of the folding at home client and also Windows. If you're deploying on Linux, then you will need to download the separate packages to install in your Linux environment. It's very simple and easy to use. You can add in a number of clients to manage all at once and still change the folding power. You can also see your slots that are available, and you can also go through the logs, system information, which Sean will show you a bit more detail around how you use that to see your GPU usage. And you can also change settings on your clients. So I'm going to add in the client that was deployed earlier today. So by default, it'll pick up a name for you, but you can change that however you want. So we'll change this to TAM Lab. My IP address is 201. My password, I'm going to respecify. And then straight away, my control unit connects to it. And then if I double click that particular client that's now been added, I can see the settings for the connections. So we can change the port that we talk on. I would recommend leaving it to the default port. We can look at the identity of the virtual machine that's being used for the client software. So again, this is replicating setting. So if, for example, you do misinput your username or your passkey, you can change it again. You can also see the slots that are there, and Sean will go into more detail about that, about using it for GPU. We can see remote access, so we can also change that remote access if we need. We can also set proxy settings, advanced parameters, so we can actually select which cores is in use. Typically, I leave my appliances for any. We can set the priority of the cores that are in use. And then finally, in the expert settings, you do have the ability to tweak as well. We have changed this so that it works as best as possible. And the tweaks that you will see, if you deploy above 16 CPUs, you will actually see a setting that is added, which is called client type. And the client type for 16 CPUs or higher is big ADV. And that lets the work servers know that your machine is larger than most of the population and can handle larger, more complex work units. You will also see an additional parameter if you select it during the deployment as well, which is called next CPU percentage. And this basically means that when we bring down the next available work unit, as we start to get to 90% complete of the current work unit, we will start looking for the next work unit to pull down as well. And I'm going to stop sharing my screen now, and I'm going to pass you over to Sean, who will take you through the configuration for GPU.
All right, well, thank you, Dean. All right, so I'm going to share out my screen here quickly. Now, what I'm going to show here is how we go about configuring the appliance to utilize a GPU. And there's a couple of things we need to do that that aren't enabled out of the box initially. So as Dean was mentioning, right, we have 3 different sizes of deployments by default: small, medium, and large. When you're using GPU, though, our small and medium size appliances don't have a lot of memory associated with them or allocated to them. So in order to actually install the Nvidia drivers, the first thing we're actually going to have to do is we're going to have to go in and edit our appliance setting. There's a couple of things we need to do here. First, we need to increase our RAM to at least 4 gig. If it's less than 4 gig, the driver install will say there's not enough space, and part of that is due to the appliance actually using some memory for the storage. So we need to also reserve all that memory, right? In order to utilize a GPU on vSphere, you have to have 100% memory reservation. Otherwise, it will not power on. Next thing we're going to do, we need to also add in our GPU. Now, there's a couple of ways we can do this. We can do pass-through. We can do vGPU. My lab is configured more for vGPU over pass-through, but the steps for installing the drivers and everything are going to be the same. So in here, we need to select our profile to go with it. Since I also have virtual desktops running, I can only use the 1Q profile. But if you have a much bigger environment or unutilized GPU resources, you can select whatever profile is going to be the best fit for you. All right, so once we get that configured, there's one other thing I should point out here too, and that is in our settings, our small appliance starts with 2 vCPU, and then we go up from there. But when we're using folding at home with a GPU, you may need to add an additional CPU. What happens is the folding at home client application is going to see that you have a GPU assigned, and it's going to carve out 1 CPU and assign it to basically work in tandem with that GPU. So if you deploy a 4 vCPU machine and then you add a GPU to it, you're only going to actually have 3 cores available for doing compute jobs. So if you want to have an even number of cores available for that compute job, or if you want to have, you don't want to lose compute resources on the appliance, you may want to assign an extra CPU just to feed that GPU. All right, so we're going to go ahead and power this on. So once we have our appliance powered on and we get our IP address and connection information, this one is also set to use DHCP. What we're going to do is we're actually going to have to SSH into the appliance to do the next steps of the setup. And it will just take a minute here to finish starting up. So what we're going to do in these next couple of steps is we're going to install the prerequisites that we need for the GPU software. Then we're going to go ahead and install the drivers, and then there's some licensing configurations that we need to do. So let's go ahead and connect to our appliance. And of course, PuTTY pulls up on the wrong screen. All right, so when we sign in with PuTTY, the first thing we're going to do is we're going to install our prerequisites. And all of these prerequisites are actually in the documentation. So we have a GPU guide up on the Fling site that will walk you through all the prerequisites that you need, as well as the commands to install them for the appliance itself. right, and this part here will just take a minute. So while we're waiting, are there any questions from what Dean demoed?
I don't have a question, but more of a comment, and maybe all of you can kind of put in your 2 cents. But I remember when this was all getting kicked off a couple months ago, and we had the Slack channel, and it was going crazy, right? And this ultimately ended up as a Fling. So for those of you that don't know, VMware Flings are essentially these little lab projects that aren't officially supported by VMware, right, if you call in for support, but a lot of times they do end up becoming products or features within products, right? So there's a lot of process around getting a Fling published, and I think we did it in like, what, 4 days or something like that? And Amanda, I know you had a huge part of that. It was just incredible to watch unfold, quote unquote, no pun intended, but it'd be great if
it was 72 hours, and it usually takes like at least 6 weeks. So it was really cool to see, you know, all the legal folks and security folks and open source folks come together and move very quickly on it.
Yeah, it's really cool to see, actually. So just wanted to call that out.
All right. So the next thing, I already have my NVIDIA drivers copied over to this appliance. We have to just make sure that they're executable, and then we are going to go ahead and run them. So when we go through and do the NVIDIA install, there is a way to do a silent install. However, I'm not going to do that for this demo. There's a couple of things I want to point out when the drivers install. Okay, apparently it's telling me I don't have the libc headers. That is new. I have not seen that error before. Okay. All right, so looks like we have an actual bug here. Wait, I see what happened. There's an L missing from the last package. All right, so the perils of doing a live demo.
Exactly. It wouldn't be a live demo otherwise.
Yeah.
Hey, Sean, I noticed you've got the FAH control there as well at the bottom.
Yep.
So if you want to, is your install finished? Or?
No, it's not, and I don't have any other appliances running at the moment.
No problem. If you open up the FAH control, one of the things that we could just quickly show them as well is, do you not have a
no, I don't have any others running right at the moment.
No problem. So.
Okay, so unfortunately today I'm running into multiple issues getting this installed. So, you know what, we will go ahead. I won't be able to show doing some of the configuration for the GPU, unfortunately. It's deciding that it does not want to pull down the prerequisites properly. But we can go ahead, we can add the client in. And I cannot type today. What is...
So that's 36.3.
Yeah.
You got it.
All right. So what we would normally do here is we would go into configure, and as Dean mentioned, under slots, this is where we can control how we assign resources to folding at home from a CPU and a GPU perspective. All right, so when we go to add a GPU, we'll go into click this add button. That'll bring up this folding slots menu. What we're going to do for GPUs, we're just going to select GPU. Now, we're not going to change anything with the GPU index, the OpenCL index, CUDA index. We're just going to go ahead and click OK. Now, that's going to bring up our GPU here as an available slot. Now, what we would normally see if the drivers were installed and it was properly licensed is in the logs, it would detect the GPU, it would detect the version of CUDA that's available, and then it would start to pull in or attempt to pull in a GPU-enabled work unit. What we would also see is that this status here for our folding slots for CPU would go from 3 to 2, because one of those CPUs would be pulled off to help support GPU compute. Now, what normally happens when you do the driver install, and I want to talk about this real quickly, is the driver install for the appliance may prompt a couple of different things depending on the type of Nvidia card you're bringing into the appliance, as well, or the type of profile that you have assigned if you're using vGPU. And what that is that you may get prompted about some things regarding graphics, right? It can't find the path for some of the graphics libraries on the system, or you may get some other errors related to those. If those pop up, just go ahead and click OK. The appliance is designed to be a headless system. There's no graphical interface on it. All right, everything that we're doing with it is GPU compute only, so you don't have to worry about those error messages. When they pop up, you can hit OK, and the driver install will complete successfully. So we're just going to check this quickly one more time. I just want to make sure I have all of the prerequisites. Next step, make utils. All right, they're all there. All right, we'll just try rerunning this driver install one more time. Just want to validate that I didn't have a typo in my command. Yeah, okay, so something's not pulling in correctly. Kernel develop, okay. Might be missing a prerequisite that was previously installed. All right, so this is using the latest version. I think I can always quickly deploy the previous version, which is part of the reason why I don't have any appliances running at the moment. All right, let's pull down the previous version. All right, while we're doing this, let's, are there any other questions in the chat?
Nothing at the moment. If anyone has anything, either put it in the chat or just unmute yourself.
Okay, so Sean, if people typically have been asking, what's the best maybe card that they could buy to put in their home server, their home lab, so that they could add GPU accelerations as well. What's your thoughts on maybe the most cost-effective way? Yeah, so the most cost-effective card you can do is you're going to want to look for an older Quadro card. So if you're looking to do this with the appliance, or if you're looking to take advantage of home lab resources that you're using for virtualization, your vSphere home lab, there are some limits on what you can do. Now, one of the challenges is that while everybody or most people have Nvidia consumer cards, what you'll find is if you try to pass through a consumer card, what's going to happen is that you're going to end up with an error when you try to pass that through, right, and install the drivers. Nvidia does not support doing consumer cards as pass through in virtualization. You need a Quadro or Professional Series card. So what I would recommend is
and you may have to go on eBay to find some of these, but you're going to want to get the Quadro P series, and there's a couple of good ones like the P2000, the P1000. You can usually find them for a couple of $100s per card. Now, these cards are certified to run in servers, so you can bring them in to any sort of server home lab hardware you have, and you can use them there. Those are the best. We've had some people try it with like the K series grid cards, the old K1s and K2s. Those are fairly old. They require a certified server to run in, and while you may be able to get them for fairly cheap, they don't have quite the same horsepower as the newer cards. Otherwise, if you're using something like VMware Workstation and you have a GTX or an RTX card, I wouldn't even try to pass that through to Workstation. Just utilize the Windows client in that case.
And of course, as well, if you do have like a graphics card or a commercial graphics card or retail graphics card rather, then you can always run the software locally on your machine anyway. I know Amanda has her own gaming machine, typically running Folding at home, and she's typically fighting for resources. Does she play online gaming, or does she let Folding at home run?
Yeah, so when I played this game, Elder Scrolls Online, it was released like 7 years ago, and people joke that it can be played on a toaster. So technically, it doesn't need a ton of resources to work. It does need a lot of resources, excuse me, to render very, very well. But I still keep the game on maximum settings and fold at medium. So medium on a 16-core machine with a GPU means that it brings it down to like 14 cores or 13 cores or something rather than 15. But then because of the way that folding at home works, it doesn't like to have a prime number as a factor, or a large prime number as a factor. So when it downloads a working unit, it often decreases the number of CPUs that it utilizes anyway. So I can play my game at, I don't know, like 40 FPS with my normal latency of my rural internet connection while folding at home on medium. But it's a pretty beefy gaming machine from Alienware, but it's still possible. I probably wouldn't do that if I was like PvP or in a serious trial or something, but just for messing around, it's good.
All right. So we have the new appliance deployed, and this will just take a minute for it to get up and ready, and then we'll be able to show the GPU install process.
So I think I had at one point 10 appliances running in my lab, and I don't have any GPUs, so it was all CPU, and it was just hammering the CPU on my host. So I forget what I was doing, but I had to spin them down because I was doing some kind of a demo. And then I never got back to spinning them up, so I'm inspired to start folding again here.
So that's terrible, Steve. So one of the interesting things to know about that is obviously you will have work units assigned to your virtual machines that haven't been active for so long. So when you receive a work unit, you will be given an amount of time to complete that work unit. So based on your characteristics of your machine, it will basically give it, quite a lengthy time past when, you could compute that if you ran it 100% all the time. And that ensures that, work units that have been distributed by researchers through the project out to people's desktops aren't laying there dormant, because obviously that means that, the whole project could be in jeopardy. So those will eventually be reassigned to other people as well. So I have been asked before when people have deleted the folding at home machines and then thought to themselves, oh no, they didn't complete fully the work units that were on there to begin with. They will be released back into the wild.
Yeah, and one other thing to add to that too is there is also a button in the folding control that will allow you to pause or to complete the existing workload that you're running, and then it will stop trying to pull down new workloads. And that button is right here. It's this button called Finish. So if you do know that you're going to need your lab for a demo or something, and you don't want to power down your appliances in the middle of a workload, you could always just click this Finish button. It's going to basically tell it to finish this up, and then it's not going to get another one. So you don't have to worry about shutting it down and never restarting it, and having those work units go back into the queue. All right, so now let's try this again. So we have our updates installed, and while that update was installing, I quickly copied over the Nvidia drivers. We're going to chmod them, then we are going to run them. Okay. All right. It looks like something changed with one of the updates that were run, because this error that's popping up is something I'll have to dig into a little bit more. It looks like it's missing the kernel source, and even on the previous version of the appliance, this was not an error that would pop up. And you'll notice here when we did our last updates, it looks like it pulled down a new kernel. So I apologize. Unfortunately, I didn't have an appliance ready to demo. That was, kind of like a good baking show where you have one in the oven ready to pull out in case something goes wrong. So unfortunately, I won't be able to show the actual driver install. But everything else we showed should be able to help people get started. And then it looks like I have some homework to do tonight on figuring out how to get around this error that's causing GPU driver install issues.
Yeah, no worries, Sean. It's of course going to happen while we're doing it live, right? But it's part of the joys of being an owner of a Fling, I suppose, right? You've always got stuff to fix and stuff to validate, stuff to test. So, anyone else got any questions? Are you guys done? Do you have other things to show?
So I guess on my side, if I share my screen again. One of the things that I missed as I was going through my flow. So I have a number of appliances running at the moment. And before we talked about seeing the process of the project that's in use with the work unit. So if I just go through mine, I've managed to find one of my clients that's working here. We can see that we're running through. We've got an estimated time to finish this work unit. We have the credit that I should be given for this work unit as well. And then we get this PRCG. And this basically, the first part of the number here is the project code that your work unit is aligned to. And then these three following numbers, they are the identifiers to the part of the protein that you are processing. So as Amanda alluded to before, we as VMware, with all of our points, have only actually completed 12 projects completely. And that's because obviously the projects are extremely large. And it takes a hell of a lot of resource. Hence, this community-based project to get those resources available to the users, to the researchers out there. So when you receive a work unit, you will actually be given a small part of a much larger research project, and your PC will be responsible for computing that part of it. And I think we kind of really covered everything else. You will see in the logs again, kind of the steps where it goes to. Occasionally, you may see, I'm just gonna see if this machine has uploaded a work unit recently. You may see, there we go. So you can see here, earlier today, this particular machine finished a work unit. It connects to the work server and sends it across, and then it will go off and it will be assigned a new work server, and then it will download the latest work packet as well. Sometimes you will see either download errors of the work units and upload errors of completed work units. Again, that's nothing to worry about too much. your machine will continue to pull down the data and also upload any data when it has errors. Sometimes the work servers that are receiving the completed work packages can get overloaded with a bulk of work packages being sent to them, and that's where those errors come from as well.
Awesome. Any other questions or comments from anyone? This is just, it's such a cool example of VMware being a force for good, right? I mean, we're never going to sell this. We're never going to make money off of this. It's just doing the right thing, right? So really cool to see it happen. I guess my last comment will be kind of a call to action. So if you've got a home lab or a powerful PC with a GPU or anything sitting there idle, check out the project and see if you can contribute, right? Otherwise, if there's nothing else, we'll call it a wrap here. All right.
Thank you very much, Sean. Thanks you very much,
Everyone.
Amanda. Thank you, Steve, and everyone for joining the call today.
Yeah, thanks everyone for presenting. This has been great. Have a good week, everybody.
Thanks, everyone. Take care.
Take care.
Thank you, everyone.